Okay, today we're going to be looking at National Data Buoy Center and how to get buoy data into RStudio. I have the web page from the National Data Buoy Center up, and we can go ahead and zoom in on this very handy map to a buoy that we may be interested in. We're just going to pick one here off of Delaware, station 44009. You can click on this, go ahead and view the history. And we have historical data that we can pick for all these different years, continuous wind data, climactic summaries, all different things. We're just going to pick some historical data from 2007, and you can either download the compressed file, or you can click this file and you can actually see the text right here. We can go ahead and just take this line right here and read this directly into RStudio. So we're going to pull up RStudio right here. I'm going to go ahead and paste this link. And we're going to put a function in here that we're going to call, well, first let's just give ourselves a couple notes here. So this is National Okay, all right, let's just call this buoy data, read.table, and we want to put I'm going to read this thing. Okay, let's go ahead and read it. All right, let's take a look at the head of this thing. And you can see we've got 18 columns here. Looks like we have some dates, and then we have a bunch of values in here. You can actually see the header on the, what the values are on the web page here. So wind direction, wind speed. The first thing we have to do is actually deal with the date. That's one of the more challenging things that we need to do in scientific data analysis. Let's go ahead and do that. So we've got year, month, day, hours, minutes. So we're going to make we're going to paste these together to make a text string of the date, and then have R convert that date into a proper time that we can use for plotting. So let's just make a function called, or object called bDate. And we're going to use the paste function, and we're going to paste together data column 1 with then a dash, and data column 2 separated by a dash, data column 3, and then now we're going to put just an empty space in here. You'll see why we're doing that in a minute. And then we're going to do data column 4. So that's now our hours. And then the next thing we're going to put in here is a colon. And then data comma 5. Another colon. And then we're going to paste in 2 zeros, and we're going to do the separation between all these is no space at all. So we're going to paste together all these things, and if we take a head of bDate, just the top, you'll see that we have 2007, which came from this column, 1-1, and we have 0 hours, 0 minutes, and 0 seconds. And then the next line, 0-0, the first hour, then the second hour, and the third hour, and so on and so forth. We want to turn those into a date. We're going to do that by requiring, I'm going to use a function or a package here called lubridate. So I'm going to go ahead and load that. And if you need to install it, you just come over here to Tools, Install Packages, and you can type in lubridate. Oops. Right, and then install dependencies if you need to, then go ahead and run this require. And we're going to run a function called year, month, day, underscore, hour, minute, seconds. That's it right there. I'm going to put bDate into this, and we're going to give it a time zone, UTC. So if we do that, you can see that we've got all of the dates now, our appropriate dates. I'm just going to overwrite this. Oops. Right, so we're just going to run bDate. It's that thing. All right. Now, let's go ahead and pull a couple of things out of here. Let's go ahead and get water temperature. Let's just call this B water temp. I think that's B date column 15, and B air temp is B date column 14. You can get that just by counting the number of columns that we have here. So here's water temp and here's air temp. Let's go ahead and plot those things together. Okay. Now, one thing to keep in mind when you look at these is that you see these 99s or these 999s. These are missing data. So one thing that we can do before we even plot them is come over here and just go B water temp is going to equal, we're going to replace B water temp where B underscore water temp is equal to 999 with an NA. So what this argument is doing is looking at B water temp, seeing where there's a 999, if there is a 999 there, putting in an NA, and then reassigning this all to our new value. So we're just overwriting the data with the 999s removed. And we can do the same thing here for air temp. All right. Go ahead and run those. Uh-oh. Oh, whoops, this shouldn't be B, this should be D, data, not date. Let's run these again. There we go. All right, so let's go ahead and now plot. Let's see, ATM, the date, and our buoy ATM, air temperature, type equals L, xlab, our x label is going to be date, and our y lab is going to equal temperature, Celsius. All right, there's our air temperature. All right, pretty standard seasonal cycle. And let's go ahead and add lines, B date, B water temp, type equals L, and color equals blue. Okay, throw our water temp on there. There it is. All right, so in the wintertime here, we got our water that is generally warmer than the air. And then over here in the fall, we've got our water generally warmer than the air. And then the rest of the year, it looks pretty similar. So that's just, you can plot many different things. We're just pulling in one buoy over 1 year, hourly data, and you can harvest as many buoys as you like and get as much data as you like.